Okay, welcome to AP Physics Physics C, Mechanics course. Here's Unit 1, kinematics. So a lot of this stuff, if you've taken a Physics 1 course before or a conceptual-based physics course, a lot of this stuff will be review at this point in time. But what's going to happen is eventually we will turn this into calculus here in a couple of videos. Okay, so this first video is going to focus on the descriptors of motion. So an object's position, an object's displacement, and the object's average velocity. All right. So the first descriptor that we're going to focus on is position. So remember, kinematics, right? That's what kinematics does. It doesn't necessarily go deep into like how all this stuff is happening, or excuse me, why this is happening. It's just like it's happening, right? So the object is moving. The object has been displaced. The object has an average velocity. Okay. So the position of an object is defined as where it is at a particular moment in time. So, for example, here in our picture with our teacher walking by the board, so her initial, we call her initial position is 1.5 meters. So she doesn't start at the origin, right? Because this is where x equals 0 or 0 meters, right? She starts away from the origin. So her initial position is 1.5 meters in reference to that origin. When she then moves, right, relative to a frame of reference, where a frame of reference is just simply a set of axes of a coordinate system that establishes our origin, right, that establishes what is moving and not moving, then her position changes. Okay, and so once her position changes, she is now displaced. So displacement is defined as change in position. Now, from a Physics 1 course, you may also have talked about a word called distance. So don't confuse this with distance, which is simply the total length between the 2 points, okay? When it comes down to it, there is only a single displacement, but there is an infinite distance that can be traveled, okay? Because you can always add one twist or turn along the way when it comes down to it in the end with distance. How do we calculate displacement? Well, I don't want to put it there. So delta x is going to be x minus x0. So our final position, which is what x is, minus our initial position, which is what xo is. All right. Now, to keep going on with our descriptors, we have to introduce this time variable, which will answer the question, how long something happened, right? So distance displacement is how far an object travels. Time is how long does it do it in. And that brings us to the third descriptor, which is what we call average velocity. So how fast an object is moving, and there's our question, right? How fast is given by the rate at which its position changes with respect to time. And the rate is a math term. It's changing quantities with respect to another. In physics, most of our quantities will change with respect to time. And we call this the average velocity. And this is very important when we distinguish, and start introducing calculus. We think about average velocity as the whole trip. Okay, so you'll see a V-bar notation, right? It's going to be change in position over the change in time. But oftentimes this time, we just call it T, or the delta T just becomes T because we just simply, our initial time is T equals 0. Okay. So now let's look at an example problem, right? Focusing centered around this, these descriptors, right? So you can read it. We got Jill at home delivering flyers. Takes her some time to deliver these, and she moves around. So when you have something like this, let's kind of like create a chart, right? Because the chart will help us with the last part of making her graph a position versus time. So time, and her position, right? So as we read through it, it says, so 0, 0, right? And this is going to be in kilometers, and time is going to be in minutes. Okay, so if we do any calculation with speed or velocity, it's going to be kilometers per minute. And so we know she's going to start at 0, 0. She walks for 9 minutes and travels positive 0.5 meters. Okay, and then she runs out of flowers and goes back home. So it takes her another 9 minutes. So now she's at total 18 minutes, but she's back at her initial position, right? And so what does that mean? So if we're tracking her displacement, right? And so displacement is going to be the difference in these these two positions, okay? And then it takes her 15 minutes. So now we're at 33 minutes, and now her position is at 1 kilometer, right? And so now her displacement, so here she does 1 kilometer, right? And then finally, the last 25 minutes, she's walking a displacement of negative 1.75 meters, which makes her position finally at 0.75 meters, right? So this is her, I forgot to label it. And so again, delta x is going to be x minus xo, okay? And so what happens is, so it says, what is the total displacement to the point where she stops at rest, okay? So this is her final position. This is her initial position, right? And so delta x is going to be x minus xo. And so that'll be delta x equals negative 0.75 minus 0, which is going to be negative 0.75 kilometers. So there's A. B is going to be what is the magnitude of her final displacement. So magnitude is simply removing or the absolute value of what we have, right? So the magnitude of her displacement is going to be 0.75 kilometers, right? Part C, the average velocity of her trip. So now we're going to use our delta x over time. And so her delta x was negative 0.75. Her time was 58 minutes. I don't know why I wrote 25 here. This should be at 58 because we're looking at total time. And so her average velocity is going to be negative 0.013 kilometers per minute because it took her 0.75 kilometers. She did it in 58 minutes. Part D is going to be what is the distance traveled? So what we're going to do to find distance traveled is we're going to take all these, remove the signs, and then add it all up. So her distance traveled is going to be 0 plus 0.5 plus 0.5 plus 1. And then this last one is going to be the tricky one because, again, distance doesn't have a direction. It just goes, okay? And so we find that she traveled a distance of 3.75 kilometers. If they ask you for average speed, this is what you'd be doing divided by 58. So you're going to see like her speed and her velocity are going to be different because technically she traveled a further distance, but her displacement was obviously less. And then finally, make a graph of her position versus time. So x versus t, x in kilometers, t in minutes, right? And so here's my axis, and she's not necessarily going to go below the axis because, actually, sorry, she will. So let me back up or erase so that we can include a negative side to this. Oops, sorry, back on eraser. So here's that, here's this. And when you plot these, you should do this carefully, but the general, how she would look, see, 1, 2, 3, 4, 5, right? So we'll call that 10, 20, right? 30, 40, 50. My scale's a little bit off. We'll go a little bit, we'll call it 60 way out here, okay? And then we'll do, see, 1, 2, 3, 4. There's 1, 1, 2, 3, 4. There's 2, -1, and -2. Okay, so there's my position versus time graph. Just kind of sketching this. So about here, she's at 0.5. Then she goes back at about 18 minutes. Right, so the first leg looks like this. Second leg does that. So her displacement is negative in that second leg. And then she's going to go 33. So here she's going to be located at 1 meter. Right, and then finally she's going to end up at -0.75 roughly out here. Okay, so right here, this is, she walked past her house. Okay, if the house is the origin, anytime you hit the x-axis on a position versus time graph, you walk past your origin. So here she's at her house, right? This is where she had to go back and get the flyers, okay? And so for this one, again, this is a lot of just simply that descriptor piece, whereas in here in the next couple of videos, then we're going to start getting into kind of that more specific information. Like the next video is going to be focusing on instantaneous speed and velocity. Then we'll talk about instantaneous and average acceleration. And then we're just going to keep building on, really just building on calculus principles from there. Okay, so again, the next video is going to be on instantaneous velocity and speed.